Okay, so today for 1, classifying triangles, we're going to begin our Unit 4. Recall that a triangle is a polygon with 3 sides. Triangles can be classified in 2 ways, by their angle measures or by their side lengths. You can think of that as having a first name and a last name. To start out with, we are going to name the vertices and the sides of the triangles. So the vertices are simply the corners or the angles. So our vertices would be angle A, angle B, and angle C. And now we want to name the sides of the triangle. So our sides would be AB, BC, and CA. So if we wanted to classify the triangles by their angles, we have 4 different kinds that we mostly deal with. Equal angular triangles, 3 60-degree angles. Equiangular means all 3 angles are equal in measure. An acute triangle means that there are 3 acute angles. Acute means that it's less than 90 degrees. A right triangle has one 90-degree angle, and then the other 2 angles would be acute. And an obtuse triangle has one obtuse angle. Remember that obtuse means greater than 90 degrees. So here's how we would solve some of these problems. We want to look at triangle BDC. All right. We have 3 angles in a triangle. We have 100 degrees, we have a 10 degree, and then we have this little piece right there that we don't exactly know what that measurement is, so we could call it X. And basically, if we add those 3 angles together, they're going to equal 180 degrees. So we could also say, to get that angle X, we would just say 180 subtract 100, and then 180 subtract 10. So that missing angle, I did the wrong thing. I'm a step ahead of myself. It just wanted us to classify it. Alright, we're classifying this triangle by its angle measures. So it has an obtuse angle right here. So this would be an obtuse triangle. I was just, doing a little preview of what's to come. All right, now we got to classify FHG. All right. If I have 2 60-degree angles, then this third angle right here would have to be 60 degrees, because if I subtracted 60 and 60 from 180, that's what I'm going to get. And so this would be an equiangular triangle. Okay, so if we think about classifying triangles by their angles, now let's classify triangles by their sides. So if we have 3 congruent sides, we would say equilateral. So 3 congruent sides. The next 2 congruent sides would be isosceles triangle. So 2 congruent sides. And the last one right here, there are no marks on this triangle, so that would indicate that all 3 of these sides are different measurements, and that's going to be a skew. So, no congruent sides. All right. When you look at a figure, you cannot assume segments are congruent based on appearance. Cannot assume. They must be marked as congruent. So if we're looking at EHF, are there sides that are marked as being congruent? Yes. 2 of those sides are congruent, so this would be an isosceles triangle. Classify ACD. All right, so if I looked at triangle ABC, I see I've got some congruency marks. So I could say that that's 15. So I've got a 15, an 18, and a 5. So this would be a skew triangle. Find the side lengths. Okay. So this side, JK, is congruent to KL, and I know that because it has the little marks on it. If 2 things are congruent, I can set them equal to each other. We've been doing that for a while now. So, my calculator. Well, my handy dandy calculator is going to tell me that 4x minus 10.7, all right, equals 2x plus 6.3. X will equal 8.5. Now, it wanted to know what each one of those side lengths was. So I have to take that 8.5 and substitute it into the expression. So one side, JK, equals 23.3. KL equals 23.3. And now I need to find JL. $44.5. So, all right, last example. Find the side lengths of equilateral FGH. All right, equilateral FGH. Equilateral means all 3 sides are going to be congruent. So I just need to pick 2 sides that I want to work with and say that they're equal to each other. Now, this equation would work. That equation would work. And that equation would work. All 3 of these would work because all 3 sides are congruent to each other. Now, I'm just going to go back and use the first one that I wrote down simply because it was the first one I wrote down. No real special reason. Clear all this out. So 3x minus 4 equals 2x plus 3. So, y is going to be 7. And now I got to substitute that in. So 3 times 7 minus 4. So 3y minus 4 is FG. So FG equals 17. GH wow, GH equals 17. And what's FH going to equal? Yeah, they're all three are equilateral. We said that at the beginning of the problem. So all three of those are going to be the same number. Now, I just substituted them into two of them just to check to see if I did anything wrong. Maybe I typed in something wrong. Maybe I solved for it incorrectly. But that's it for today.